All right, so this is our part 2 of the review of derivative skills. Again, if you would have pencil and paper ready so that you can go through these with me. Okay, so what we're going to do now is we're going to go ahead and start looking at what happens when we work with the chain rule. And when we discussed this in class, we said that there was this outside piece and there was this inside piece. And if we understood that we basically had a composition of functions, it became a little bit easier for us to do, thinking about it as outside and inside. So the first thing that we're going to do is take f of x and say our derivative is f prime of x. We're going to take our exponent, multiply it by our coefficient in front. Our coefficient in front here is a 1, so 10 times 1 is 10. The inside stays the same. We decrease the power of 10 by 1 to 9. Now we go inside to what I've got underlined in pink and take the derivative of 7 minus x cubed, and that becomes negative 3x squared. And we're done. Okay, so this one, it looks like we have 2 times this big function inside, all raised to the negative 5th power. So we certainly have some things that we want to think about here. I think everybody would agree that inside we've got a quotient. So we'll definitely use quotient rule at some point when we're talking about a derivative inside. But let's get started and see how it comes together. So the very first thing that we're going to do is recognize that we are taking the derivative of m of a. Okay, so negative 5 is going to swing down and multiply by 2. So we're going to have negative 10. We keep the inside exactly as it is, so that would be 7 minus a over a cubed minus a. Decrease the power of 1 by 1, we go to negative 6. Well, now we want to take the derivative of the inside, so that's where this is going to get a little bit messy perhaps for us. When we go to take the derivative of the inside, we know that we've got quotient rule. So I'm going to use brackets just to keep it neat. So we're going to say the bottom, which is a cubed minus a, times the derivative of the top. The derivative of the top is just going to be negative 1, right? Minus the top, 7 minus a, times the derivative of the bottom, which would be 3a squared, minus 1, all over the bottom squared. So a cubed minus a to the 2nd power. Wow. And I think we're done there. So again, we took the derivative of the outside. That is our very first piece that you can see right here. And then we took the derivative of the inside, and as we took the derivative of the inside, that involved quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Okay, so why don't you pause here for a second, see what you can do with it before you actually see me work through it. Okay, so I'm going to say f prime of r is equal to, I'm hoping that you all see that really what we've got here is a product. And our first term is r squared, and our second term is actually this whole chain rule piece. So it looks like the big idea in this function, the big idea is basically that we're going to work with product rule. So let's go ahead and get started. I think I'm going to go under here to save some room. But it looks like I'm going to have the first, which is r squared, times the derivative of the second. So I might use grouping symbol here. So there's my bracket. So I'm going to bring down 2/3 inside 2 minus 5 over r. Then I'm going to drop 2/3 by 1, gives me negative 1/3. Then I'm going to go inside and take the derivative of the inside. Well, remember this piece right here is really minus 5r to the negative 1. So I want to be careful as I'm looking at the derivative of the inside. That would become 5r to the negative 2. And then we always stop and take a breather at where we are. So this again is the first. This whole thing here is the derivative of the second, right? Now we're going to say plus the second times the derivative of the first. Make this a little bit smaller. Plus, okay, so now we've got the second, which would be 2 minus 5 over r to the 2/3 times the derivative of the first, which would be 2r. All right, so I'm hoping that that's what you came up with. Again, we don't need to simplify. I think the biggest thing that I want to make sure that I point out here is that when you're looking at your original function, one of the most important things to understand is that you cannot take 2/3 and simply multiply it down. You can't do that. You have got to split it up into your first and your second and move through it using product rule. Okay, let's take a minute now and really talk about our e function and our ln function. You know, e is this pretty famous number that you've heard about, and ln is a logarithm whose base is base e. So what we want to do is understand that in calculus, those functions come up quite often, and we want to be able to take the derivatives and down the road antiderivatives of these functions. The basic rules are so obvious that sometimes people get confused. So we kind of do the basic rules and the chain rule with them all together. The basic rule for the e function, if I have f of x is equal to e to the x, the derivative, believe it or not, is exactly the same thing. F prime of x is equal to e to the x. Well, if f of x is equal to ln x, then the derivative f prime of x is simply equal to 1 over x. Those rules are very simple, but they transform into something that uses the chain rule very quickly, so I want to make sure that we do that transition here. Okay, so this is how our e function and our ln function uses chain rule. If you look at this example that I've given, you notice that all of a sudden it's not just e to some power. It's e to the 2x plus 1 power. Well, what we do is we identify the exponent, and the way that the chain rule kind of deploys in a problem like this is we end up going, all right, well, we know that the derivative of an e function is e to whatever exponent it already has. But then we're going to turn around and multiply by the derivative of the exponent. If I wanted to simplify it to this, I could. 2e to the 2x plus 1. Works out pretty nice, pretty simple, but we just need to make sure that we understand the basics. In this one, we don't have just an x. In fact, we've got a different variable altogether, but the piece that we're taking the natural log of, h squared minus the square root of h. So what we're going to do with this is we are basically going to take and do what we did earlier, where we're going to say, all right, well, g prime of h, the very first thing that I do is I write 1 over h squared minus the square root of h. But then I turn around and I take the derivative of just this piece. So the derivative of that piece is 2h minus 1/2 h to the negative 1/2. Remember, off to the side, I knew that the square root of h originally was h to the 1/2 power. So this business with e and ln is not difficult. It just takes the chain rule and applies taking the derivative of the exponent or the piece that we're taking the natural log of. All right, so with this next example, the first thing I want to point out is that it is 2e to the x minus 5 power multiplied by ln x squared. So if we've got a first and a second, right, we're using product rule. Really, really important. So with product rule, we know that we're going to move through this in a special way. So f prime of x is going to be the first, 2e, I'm going to put my exponent in parentheses, x minus 5, there's my first, I'm going to use a grouping symbol, times the derivative of my second. Well, that would be 1 over x squared, but then I'm going to turn around and multiply by the derivative of x squared, which is 2x. So far, I've got the first and the derivative of the second. Now what I want to do is I want to add that to the second, which is ln x squared, times the derivative of the first. Okay, so the derivative of the first, we're going to write it exactly as we see it, right? 2e to the x minus 5. Well, when I go back in and I take the derivative of the exponent, x minus 5, that's just 1. Some of you may not even put that, and that's okay. But again, when you look through this, we have the first term times the derivative of the second, plus the second term times the derivative of the first. And we're done. Remember, you can pause this at any time and do what you need to do to kind of work through it. Let's move on to this next one, the one that's written in red here, g of a. So with g of a, looks like we've got some minus signs along the way. So how am I going to deal with that? Let's think about that a little bit. G prime of a is actually going to be, well, the derivative of 7 by itself is 0. And I know that some of you might put 0, so I'm going to put it there just to show you what's going on. Then I move to this next piece. And the derivative of just that piece is going to be, well, negative 5e to the 7x squared. But I've got to turn around and take the derivative of my exponent, which would be 14x. So 0 was the derivative of the 7. 5e to the 7x squared times 14x is the derivative of that middle piece, 5e to the 7x squared. Then I move down to my last piece, and I'm going to say, oh, okay, well, the derivative of ln x squared minus 5x is going to be 1 over x squared minus 5x times the derivative of the thing that I'm taking the natural log of, so that would become 2x minus 5. And I would encourage grouping symbols. The other thing that I want to point out that some of you may already understand is that sometimes when we look at our answers in WebAssign, they don't always look exactly like what we have. So let me make sure that you understand how you might see something written in WebAssign. WebAssign perhaps would take and basically say g prime of a is equal to negative 70 x e to the 7x squared. And think about what they did. They just took all of this, they multiplied 14, right, times 5 to get their 70 e to the 7x squared. And then over in the next part, probably you would see it as 2x minus 5 over x squared minus 5, minus 5x. Little typo there, right? 1 over x squared minus 5x times 2x minus 5, but this may be the simplified version. If you were trying to, it's really not that it's simplified, but it's really just kind of taking and tying up some loose ends there.